Hello, I'm Yue. Nice to meet you. I'm doing my PhD at CMU. At CMU, I'm working with Professor Lama, a co-glue on automated machine learning, Professor Zhao on machine learning systems. Externally, I have been working with Professor Yuri Laskovac from Stanford and also Professor Philip Yu from USC. My current research has unsupervised machine learning algorithms and systems. Why it's important? Because we're generating so much data nowadays. And all this data usually comes only with the observation X, but not the outcome or the ground truth label Y. So because of that, it's not easy to build a supervised machine learning model map from X to Y. So because of that, we want to focus on the unsupervised machine learning in my research for now. As you can see, there's a lot of interesting applications. For example, outlier detection, which means identify the data which are different from the general data distribution. This can be used for fraud detection, rare disease detection, and much more. Also, in the middle, you will see the model compression and the data compression using unsupervised machine learning, which is very meaningful for tiny and edge ML and also machine learning systems. On the right, you will see the clustering, which means people can use this clustering technique to identify the client information, patterns, behaviors, etc. Also, we can identify interesting patterns in the gene expression, which is very, very useful in the healthcare as well. Although unsupervised machine learning is important, it has a lot of challenges in applying that. The first challenge will be the automation part. You can see from the screen, giving a lot of machine learning models for the unsupervised ML, how to select a good one for your deployment. This can be hard because you don't have value, so you couldn't do the ground truth evaluation, which is very challenging. On the right, which is the system part, because you have so much data for unsupervised ML, how to build scalable systems for deploying such a large-scale machine learning task will be very challenging. Interestingly, my work actually is in the intersection of both. I'm doing both automation and scalable machine learning systems for unsupervised ML. And here, this slide actually shows my core work as the following. Given some machine learning task, on the left, you can see I'm doing model selection, hyperparameter optimization, which is actually the automation of the unsupervised ML. In the middle, you will see I build systems to deploy the large-scale machine learning applications after the model selection. Finally, you can see I'm doing fair evaluation of the machine learning models for the unsupervised ML. So you can say my work actually covers the full spectrum of ML lifecycle, which is very important, and you're welcome to check out. This will be the automation part of my work. You can see from the left, I'm building something called MetaOD in 2021 in Europe, which we're building the first unsupervised outlier detection model selection. And on the right, you can see we'll keep doing this for hyperparameter optimization and etc., which is very important for the practitioners and also the researchers. This will be the summary of my system works. You can see I'm building the system for CPUs, GPUs. I'm also building the works for time series data, graph data in all different data modalities, which provides us pretty holistic solutions for system support. And I'm also advocates for interdisciplinary research in machine learning plus X. So which means machine learning plus security, machine learning plus finance, machine learning plus drug discovery, machine learning plus bioinformatics and healthcare. I'm building open source all the time. I think that's an important part to make a real world impact. As you can see, my Python outlier detection library has been downloaded by more than 10 million times with 500 citations already. It has been used in Morgan Stanley, Tesla, Wells Fargo for different applications. Also, I'm pretty honored to join the projects including the TDC for AI drug discovery, PyGuard for graph outlier detection, and PyG for PyTorch geometric learning. Finally, I want to talk about something about my teaching experience and my philosophy regarding that. First of all, I have been the teaching assistant or the guest lecturer for more than 10 courses until now. I'm doing this for the ECS programming labs. I'm doing this for the AI and stats courses. I'm also doing this for the business analytic courses at B School. So I have a rich experience in teaching. Also, my teaching philosophy will be knowing why before knowing how. And in the future, I plan to teach the following courses. The first set will be the existing courses in AI, ML, stats, and programming. I'm pretty happy to teach both the introductory level and also the advanced level courses in these fields. Also, I'm proposing, or I know some of the places have applied machine learning, which is my favorite. I can do this course or design this new course or polish the course. Also, I want to propose a new course called machine learning systems, which means we want to know how to use machine learning system technique to enable machine learning, or vice versa, how to use a system technique to make ML more scalable, automated, etc. I hope you enjoy this talk, and thanks.